Hi, I'm Pete Starkey with iConnect 007 here in Productronica, and delighted to have the opportunity to visit with the guys at Electra Polymers and to meet old friends Ashley Steers and Shaun Tibbals. Ashley, Shaun, thanks very much for sparing the time. I know how busy you are today. Yeah. Could I turn to you first, Ashley? And we're standing in front of a big banner that says soldermask for the digital era. Can you bring us up to speed on direct imaging soldermask?
Yeah, absolutely. Direct imaging soldermask, it's been around for a little while now, but really starting to sort of push into becoming mainstream. We've got a product now which is established on a wide variety of direct imaging machines. Customers are really looking for reliability, which is very important. Not just reliability though, but speed of process. Exposure speeds are still, everybody wants faster exposure, more capacity to run through the machines. So
could you put some numbers on exposure speed, provided you've got the right machine? What sort of throughput can you achieve?
Numbers on the, if you look at it from a millijoule value, you can be as low as 80 millijoules up to, depending on your copper weights and your features, up to around 150, maybe even 200 millijoules. But typically 100, 120 is where most people are sitting, and that on the faster machines is around 40 seconds per side.
So that's meaningful in production terms?
Yeah, I think so, yeah. And it's the sort of the reliability of the process as well, being able to consistently run, not have to worry about registration and your films and everything. So it really has been certainly for Electra, it's been a really strong product, and it's really fueling the growth for Electra in the digital market.
What are the popular coating methods for this generation of solder masks?
Really, it's screen printing and spraying, and for the future will be inkjetting. We're seeing it's not necessarily a direct imaging solder mask. It is a digital imaging solder mask. Yeah. But mostly spray, screen printing are the two sort of forerunners at the moment.
You mentioned inkjet. Would you use the same sort of formulation for inkjet as you would use for DI?
No. I believe I'm right in saying there's not a single component or raw material in the standard solder mask as there would be in the inkjet solder mask. So it's not a case of just adding some solvent to the existing solder mask and put it in your inkjet and off you go. It's a completely different product.
So, I remember somebody said some years ago, if you can formulate it to meet end user approval, you can't jet it, and if you can jet it, you can't.
Well, we're getting there. We are getting there. We can't put out a product which isn't going to meet the requirements. It's not a product. So we are getting there. Yeah.
These are now mature products.
Certainly the DI. The DI solder mask is mature, it's established, and it's fueling the growth for our company. Yeah. We're having a good year. We've gained significant amounts of new accounts with the DI product. It seems to be the in thing at the moment. Certainly for us, a lot of attention.
In what geographical areas is the sort of the DI process is popular?
Personally, I'm responsible for the European markets, and we're seeing a lot of growth there, a lot of investment there. I know in the stateside they're also really pushing that technology along as well, and I'm fairly confident in saying that in Asia it's starting to pick up as well. But for us, and really at the moment, it's in the Americas and within Europe. Yeah.
Shaun, thanks for that. Ashley, thanks for that. Shaun, could I turn to you, please? Ashley's already spoken a little about inkjet, but can you bring us up to speed with current developments in that direction?
Yeah, sure. In terms of development activities within the PCB sector, inkjet certainly is one of the highest activities we've got going on at the moment in terms of R&D. Inkjet technology really is the first step change in solder mask technology since probably Prober 52 back in the 80s, something you'll know very much about.
Yeah.
Because since then we've had evolution of photoimage. We've gone from aqueous to solvent, we've gone from flood exposure to direct image, but they're all variations of a theme. With inkjet, we really are changing the model with direct write, very little wastage. So, and what comes with that is a large amount of R&D activity, not only in the chemistry but also in the equipment itself, both the integration of the heads and the head technology as well.
Yeah.
So now in terms of material, we're coming now to the final stages of the development. And I think if you look at where we are now with the materials and look at where the equipment guys are and the head manufacturers, I think 2018 is going to be actually a very exciting year for inkjet solder mask.
Yeah. Have you got sort of open cooperation with the equipment suppliers in terms of joint development?
Definitely. I mean, we have to work with the integrators. So not only have we got to work with the head manufacturers, but then we've got to work with the integrators. So the guys that are taking those heads and putting them into a functional unit. So ourselves, we have to have an inkjet machine in-house. So we have an inkjet machine in our laboratory where we can run materials on a range of heads. So we're running currently with a Konica Minolta head, a 1024i, which is quite a universal head. But there's some new technologies coming along with MEMS type heads running different viscosities of material, much smaller droplet size, and now down into the 3 to 6 picolitre range. So some very exciting developments.
So you can achieve some pretty sharp resolution at those drop sizes?
Yes, you can. Yeah. So I mean, effectively, we're looking to be able to resolve 3 to 4 mil dams, so 7,500 micron solder dams. I mean, they're not going to look like a conventional photoimage solder dam, but then we have to ask ourselves the question: do they really need to?
That's the question. You know, if you look at an edge cross section, it's entirely different. On the one hand, you've got a sharp sidewall. On the other hand, you've got some form of meniscus. But as you say, what will fulfil the requirement?
Well, as long as we're stopping the pads from bridging during assembly, then that will be okay. So I think the OEM involvement is going to be very important, and the acceptance of something which looks different but still fulfills the technical requirements. We've got to involve them at the early stages. So our job right now is to make sure that the solder mask ticks every single box in terms of SM840, nickel gold, immersion tin, automotive testing, high reliability, and then we've got to go to the OEMs and get them on board. So it's one thing to have a compliance with international specifications, but certainly the sort of marketplaces that you've mentioned, you've just got to satisfy the end user. Absolutely. If they're not on board, then the technology will really struggle to make it mainstream. And we don't want it to be niche. In terms of for Electra, we see this as strategically a really important step. Maybe not for the next 1 or 2 years, but it would be lovely to be able to walk into a solder mask department in 5 years' time, 10 years' time, and you'll see a range of inkjet machines just churning out circuit boards instead of a range of screen printing machines, a developing machine, umpteen exposure units, all using huge amounts of energy and huge amounts of water. So I think it's an exciting time.
That's right. Shaun, if you look sort of outside of the mainstream PCB industry, in what other markets have you made developments and improvements?
So I mean, another important sector for us is the semiconductor and wafer-level packaging industry. So we now see that as probably accounting for at least 40% of our business now, and a large amount of R&D activity goes into that.
So what sort of products are you supplying into that sector?
So there'll be dielectric materials, passivation layers, range of different applications. Some of them are generic, but many of them are developed alongside the wafer-level packaging companies for very much bespoke applications. And they may be light filters, maybe an infrared filter, a UV filter, which is incorporated into the actual package itself. Now, the development time for these things may be 1 or 2 years, but actually after that, then once they start to go into volume production, then they really are a nice bit of business, and we're starting to reap the benefits of that. We've got a number of products which were developed 1 or 2 years ago, which we're seeing going into volume production now in automotive, smartphone applications.
What sort of process technologies are involved in that sector?
They're generally spin coated or they may be spray coated, but a very different spray coat to the PCB spray coat. Yeah. So these would be an ultrasonic spray coat. They're sprayed at extremely low viscosities, actually not dissimilar to an inkjet viscosity. Yeah. And they're very tiny particle size, so they're all nanoparticle materials.
To achieve what sort of coating thickness?
Ranges from, they probably would go as low as 5 to 10 up to 40. Yeah. So, and I say, what's really good is actually that the semiconductor industry is particularly buoyant at the moment. So we're seeing huge growth in that organically, but also with these new technologies coming on stream, it's having a major impact on our business. Yeah. And you know, I think we're probably on for what will be our best year ever this year. Yeah. So together with the DI material and then the wafer level packaging materials, it's an exciting time. So yeah.
Well, as I say, we know you're busy, and we really appreciate the time you spent explaining to us. Shaun, thank you very much indeed. Ashley, thank you very much indeed. Pete Starkey, iConnect 007 at Productronica. Thank you.